Imagine a world where the internet itself is a computer, a vast, decentralized network that can host websites, run applications, and store data. This isn't science fiction, it's the Internet Computer Protocol, or ICP for short. ICP is a groundbreaking blockchain technology that's pushing the boundaries of what's possible in the digital realm. Unlike traditional blockchains that focus solely on cryptocurrency transactions, ICP aims to revolutionize how we interact with the internet. It's like comparing a bicycle to a spaceship. Both will get you from point A to point B, but one opens up entirely new horizons. ICP isn't just about sending digital money, it's about creating a new, decentralized internet infrastructure. What sets ICP apart is its ability to run at web speed. Most blockchains are slow, processing only a handful of transactions per second. ICP, on the other hand, can handle thousands of transactions in the blink of an eye. It's like comparing a snail's pace to the speed of light. This incredible speed opens up possibilities for decentralized applications that were once thought impossible. But speed isn't the only trick up ICP's sleeve. It also offers unlimited scalability. As more users join the network, it doesn't slow down. Instead, it grows stronger and faster. Imagine a highway that adds more lanes as traffic increases, ensuring smooth travel no matter how many cars join the road. That's the power of ICP's scalability. At the heart of ICP lies its native token, also called ICP. But don't be fooled into thinking it's just another cryptocurrency. The ICP token is the lifeblood of the entire ecosystem. It's used for governance, to create cycles, more on that later, and to reward node providers. Think of it as the universal currency of this new digital world. What truly sets ICP apart is how it implements tokens using smart contracts. In the world of ICP, everything is a canister, a smart contract that can hold tokens. This approach, known as the ICRC2 standard, allows for incredible flexibility. Imagine being able to create your own custom token with just a few lines of code. That's the power of ICP's token system. But why is this important? Well, it opens up a world of possibilities for developers and users alike. Want to create a decentralized social media platform with its own reward system? Easy. How about a game where in-game items are truly owned by players as tokens? No problem. The ICRC2 standard makes all of this possible and more. And here's the kicker. These tokens can interact seamlessly with each other. It's like having a universal translator for digital assets. No more complicated bridges or swaps between different blockchain ecosystems. In the world of ICP, everything speaks the same language, making interoperability a breeze. Now let's talk about how ICP handles operations. In traditional blockchains like Ethereum, everything revolves around transactions. You send a transaction, wait for it to be mined, and hope it goes through. It's like sending a letter and anxiously waiting for a reply. ICP takes a different approach. It uses messages. Messages in ICP are like instant messaging for smart contracts. When one canister, remember that's ICP's term for a smart contract, wants to interact with another, it sends a message. This happens almost instantly, with no waiting or mining required. It's like the difference between sending a letter and having a real-time conversation. This messaging system allows for incredibly complex operations to happen in the blink of an eye. Imagine a decentralized application that needs to interact with multiple smart contracts to complete a task. In a traditional blockchain, this could take minutes or even hours. On ICP, it happens in milliseconds. It's like the difference between a game of chess by mail and a rapid-fire video game. But the benefits of messages go beyond just speed. They also allow for more natural programming models. Developers can think in terms of function calls and responses, just like they would in traditional software development. This makes creating decentralized applications on ICP feel more intuitive and less like wrestling with blockchain quirks. Section 4 cycles fueling the internet computer. Now let's talk about something truly unique to ICP, cycles. In most blockchains, you pay for transactions with the native cryptocurrency. On Ethereum, that's gas paid in ETH. ICP flips this model on its head with what's called the reverse gas model using cycles. Cycles are like the fuel that powers computations on the internet computer. But here's the twist. Users don't pay for cycles directly. Instead, developers preload their canisters with cycles. When a user interacts with a dApp, the canister burns cycles to perform the computation. It's like going to an all-inclusive resort where everything is already paid for. This model has huge implications for user experience. Imagine never having to worry about gas fees or transaction costs when using a DApp. That's the reality on ICP. Users can interact with applications freely without needing to own any cryptocurrency. It's like being able to use the internet without having to pay for each website you visit. For developers, cycles provide predictable costs and the ability to subsidize user interactions. They can choose to absorb the costs of running their DApp or implement creative tokenomics to generate cycles. This flexibility allows for innovative business models that simply aren't possible on other blockchains. Section 5. The Network Nervous System. Governance in Action. Governance is a hot topic in the blockchain world, and ICP takes a unique approach with its Network Nervous System, or NNS. Think of the NNS as the brain of the internet computer. It's not just a voting system. It's an adaptive AI-powered decision-making engine that controls every aspect of the network. The NNS is responsible for crucial tasks like adding new nodes, creating subnets, upgrading the protocol, and even setting the rewards for node providers. But here's where it gets interesting. Anyone holding ICP tokens can participate in governance by staking their tokens and voting on proposals. It's like a futuristic direct democracy where every token holder has a say. What makes the NNS truly revolutionary is its ability to make decisions autonomously. It doesn't rely on a small group of developers or a foundation. Instead, it uses advanced algorithms to weigh votes and make decisions that benefit the entire network. Imagine if your city's infrastructure could automatically decide when to repair roads or upgrade power lines based on real-time data and citizen input. That's the level of automation the NNS brings to blockchain governance. But the NNS isn't just about making decisions, it also plays a crucial role in the tokenomics of ICP. When you stake your ICP tokens to participate in governance, you earn rewards. This creates a powerful incentive for long-term holding and active participation in the network's future. It's like being a shareholder and board member of the internet itself. Section 6. Node Providers, the backbone of ICP. Last but certainly not least, let's talk about the unsung heroes of the internet computer, the node providers. These are the individuals and organizations that contribute computing power to the network, forming the physical infrastructure that makes ICP possible. It's like being a landlord in the digital realm, providing space for the internet to exist. Becoming a node provider on ICP is no small feat. It requires powerful hardware, a stable internet connection, and a significant investment in ICP tokens. But the rewards can be substantial. Node providers earn cycles for their contributions, which can be converted back into ICP tokens. It's like mining in traditional blockchains, but with a focus on providing useful computation rather than solving arbitrary puzzles. What sets ICP's node system apart is its focus on decentralization and security. Node providers are spread across the globe, ensuring that no single entity or government can control the network. Each data center is independently owned and operated, creating a truly decentralized infrastructure. It's like having a global network of independent libraries, each holding a piece of humanity's digital knowledge. The process of becoming a node provider is carefully managed by the NNS. This ensures that only qualified providers join the network, maintaining high standards of performance and security. It's a delicate balance between growth and quality control, ensuring that the internet computer remains fast, reliable, and secure as it expands.